All right. Happy Labor Day, everyone. Thanks for many of you for showing up. I appreciated it. Tuesdays are bad for me, and when I didn't want to wait till Wednesday. So, for those who are watching later, I hope you had a lovely Labor Day. Um, before we start, I completely forgot I had written a whole slide, and I didn't put it in the slide deck last week. But it can't. Someone, but anyways, I wanted to be a little bit more explicit about AI this semester. So this actually, I should have talked about this last week. I'm so sorry. But someone did ask like what the use of, what's policy regarding AI. I think Angela and I both sort of expect, you to do your own work, right? And so schools had an academic policy since the beginning of, time. And, cheating or plagiarism is just, not acceptable. And if you don't know what plagiarism is, there's a link on the syllabus. But AI has kind of complicated things. Um, and so first thing I want to say is I kind of hate the term AI. It's a marketing term. I think it lacks specific meaning. So when people use AI, they generally mean one of two things. One is machine learning, which has been around forever. This course is laying the foundations to do machine learning, right? Regression is probably still a widely used machine learning algorithm, if you will. Like it's like, trying to make predictions and what have you. So, oh, I copied this from my other course. That's why I didn't end up here. That should be data through 606. Um, uh, okay, so that's clear. We're going to talk about that. But I think what people generally want to know is like large language models, right? The chat GPT, the chat models, where you ask a question, you get an answer. So you could probably take all the assignments and put them in chat GPT and get an answer. Problem is you guys are, I imagine most of you are new data scientists, so you will have no idea if it's correct or not. So, my advice is to avoid using the chatbots. And if you're using them, use them, when you get stuck, right? As a way of kind of nudging you forward. And use the ones like Anthropic, I think is pretty decent because you can say, well, give me references and links to resources. Um, I didn't get to it this week. I'm actually working on a RAG model, a retrieval augmented document. So I built the model. I got it running locally, but I'm building a Shiny app to go around it. So hopefully soon I'll have one that you can create an account and log in. And the notion there is I've curated a list of resources that I know are trustworthy. And I've wrote a system prompt to say, to get it to try to limit the answers to what's available and the resources that I said are authoritative. And then if not, I can go and get a couple of other answers in a more general way. Um, this is new, I think, for me and Angela. And instead of saying you can't use it, my position is you can use it, but include the prompts and answers in, just put them at the bottom of the lab if you use them in a lab or some other place. Um, because we're learning along with you. We need to figure out a way to teach responsible use of AI. Um, so I'm a bit of a skeptic. I think the AI bubble is going to burst. I think this year. I think it's going to happen soon. I think ChatGPT 5 is sort of an indicator that people are wising up that this notion that we're going to get to generalized intelligence is kind of bunk, right? These are still probability machines, and so maybe I'll talk about it from time to time in this course of you know a little bit of how they work. And more of the advanced courses you can do that. So if you have any questions, concerns, comments, you can throw them in the chat. You can on Chime, but so you can just tell us what you're using. We're not going to penalize you if you unless you just gave it the whole lab and say finish my lab for me. That's I don't think that's responsible, right? You need to. I think these could be very useful tools, and Anthropic, I think in particular, is good at R programming. So if you're stuck on R commands, I think it's a great way of helping debug. But I will tell you, in trying to ask it to get me started on some projects, it's uh, last couple of times I copy and paste it in, and it goes, "Oh, I don't have that R package. Oh, there is no R package that exists with that name, right? So it just literally made up an R package. Uh, those are the kinds of things you gotta be able to work through because they are often wrong. Okay, let's move on. I don't want to belabor the point more than I already have. So now we're going to talk about data. Oh, but first data I want to talk about is so thank you for all of you who completed the Google form. So these are some of the results in aggregate. And so asked about familiarity. So everybody's somewhat familiar with like probability, correlation, data visualization. This is all great. Descriptive stats, a lot of Python familiarity, some familiarity with R, which is fantastic. That's great. Um, I'm glad SPSS is kind of almost unfamiliar. That's a holdover. I've been using this survey for a very long time, and I've taught in social sciences, so that's where I'm kind of, if I was teaching this in a social sciences context, that would probably be reversed. Nova, chi-squared. Okay, so these are, if you can't guess, these are all things we're going to talk about this semester. So even if you're familiar, my hope is that you have a much deeper understanding in 14 weeks on these topics. So this is a good start, I think. Great. And then I think we also asked you to do the self-regulated learning assessment. So you probably realize, or we talked about, Angela and I are really big in formative assessment and student success, and et cetera, et cetera. And one of the things we've learned over the years is like anxiety scales. Like we've used testing anxiety more broadly, and we've looked at like efficacy, which is one's belief in their, belief. So this is math anxiety and affect. So it's like your attitudes and your anxiety towards math. These kinds of things are actually often better predictors of student success than, baseline content knowledge. And so I scanned through this earlier. This all is great. You are going to either one person who strongly disagrees that they're going to use math in the future. Maybe if you're going to management or something, data science, okay. But if you're a data scientist, you're using math. I'm sorry. Um, uh, find math interesting. That's great. And then I look at the bottom side, right? Most of you don't really feel too confused. I should at one point throw in like some results from like when I taught in criminal justice or education because it's a very different plot. So this is good. I kind of expect this for data scientists. I do want to say for both Angela and I, we don't want you to feel terribly overwhelmed. I think there's a productive type form of overwhelmed where you might keep you going, but like, um, just reach out, and you're not in this alone. So talk to us. We don't mean to make you feel anxious. If you feel anxious, we're, here to help. Okay, questions, concerns, again, throw them in the chat or we can just chime in. Tonight we're going to talk a little bit about, and hopefully Angela will chime in on the validity, because I just did this an hour and a half ago and I forgot some stuff. This slide deck is a lot about where does data come from? And I've looked at a lot of data, intro to data science workshop, all these intro to data, works, they might start with like, here's your data file. Here, you load it into R or Python, and then you start doing analysis. But we want to step back and say you know, not like where's it come from, like which CSV file does it, or which database is like where, like what are we talking about and what are the measures we're talking about. Next week we talk about like summarizing data. We're going to get into like the dplyr and this notion of in the data science world, if you're reading the R for Data Science book, Hadley kind of refers to this as tidy data, right? Tidy data simply means, for tonight we'll talk about like where a table where each row represents your research of interest or your subject, your research subject, if you will, right? For Angela and I, it's often students. If you're doing lab work, it might be mice. If you're doing, uh, you know, um, if you're doing financial stuff, it may be a company, right? But the notion is like the rows represent some entity of interest, and then the columns represent measurements or variables. Okay, and some things are, it could be very clear if you're talking about, sex, gender, social economic status, like those are kinds of variables we look at in educational context, financial, or if you're doing companies, might be, whatever, revenue or what have you. So some of these measures, right, can easily be or when we talk about variables, we want them to be valid and reliable, right? And so, meaning validity is really about the notion that what we're measuring is what we think it's measuring. And a lot of times we measure things and they may measure something similar, but not exactly what we want, right? And then reliability is about, well, if we're measuring this and if we do it repeatedly, we get consistent results. Um, and so the bottom here, we have like this bullseye kind of metaphor where if our goal is to hit the target, right, this one is not reliable, it's not valid, right? The darts are all over the place. Now, you can very often have reliable measures that aren't valid, right? They might be consistent, but they're not measuring what you think they're measuring, right? So I would argue in some content, in some way, SAT scores, right, which are, used to college admissions are certainly reliable, right? There's psychometricians, statisticians who show that like you get the same person, they score over and over, but it's designed to measure college readiness. And I'm not sure it's entirely valid because there are a lot of people who do poorly on SAT and are successful and vice versa, right? And actually we see this systematically in certain subgroups. So what we ideally want is measures that are both valid and reliable. Okay. As data scientists, we don't talk about this enough. Um, we don't talk about this enough. We just kind of blindly put variables in a model. We look at predictions. We get, um, and we may or may not be measuring. Now, Angela, do you want to chime in a little bit because you're more of the expert on, like, in terms of like validity evidence, right? There's sort of five major arguments that you could look at.
Yeah, so there's actually a couple of different approaches or frameworks that measurement scholars use. Ones that some of you might be familiar with is the Trinitarian, which focuses on three sources of validity. So there is content, criterion, and consequences. But then the one that is more popular nowadays because it's been published in the standards. That's like a Bible for measurement. The standards of educational and psychological testing. They focus on validity evidence, sources of validity evidence, because it's the unitary framework that claims that we are looking for evidence that supports the fact that a measure or a test is measuring the construct that we are intended to measure, right? And so the overarching validity is construct validity, but we have different sources of validity evidence. So one is uh, content validity evidence, which focuses on, oh, is this question like a math question? Um, Addressing math, or is it really addressing reading? Because there is so much comprehension that is involved in having to understand that question before math knowledge can be assessed, right? And so that's content. And then there's response processes, which is our students interpreting these questions in the way that we as developers intend for students to interpret these questions, right? And so one of the popular examples is, are students really just guessing and getting to the right answer, or are we really measuring, are students really going through the process that we intend for students to go through in order to answer that math question? Internal structure has to do with how well the items all together hang together to measure that particular construct. So, for example, if we're measuring math, and there's a math test, are all of those items measuring math in similar ways, but not exactly the same, so that it's not redundant, but it is measuring that math construct in the way students' math ability or math performance. So that requires us to do statistical analyses like exploratory factor analysis or confirmatory factor analyses, things like that. Relations with other variables is has to do with our um, is the measure the performance correlated with other performance, students' performance on other measures that are similar, measuring the same or similar constructs, right? And so for those, we will want the relations, the correlations to be pretty high. But if we're saying um, that we don't want this measure to be measuring something else, then that correlation should be low. So an example, a common example is a measure of depression versus anxiety, right? And so we know for a fact that those constructs, anxiety and depression, are related, but they are not the same. And so we want to expect to see correlations that are similar. I mean, that are moderately, not even moderately, just we expect to see some correlation, but not too high, right? Because they are measuring two different things. Whereas if we have a long version of a depression scale and a short version of a depression scale, that correlation we expect to be a lot higher than the correlation between anxiety and depression. And then consequences is a more it has to do with the uses and purposes and whether or not the test and is being used in the way that we intend, and if the consequences that are elicited based on the use of the test is intended or not intended. And so there are some negative consequences to placement exams, for example, or using diagnostic assessments for placement purposes. And so that's why for DAX, we always emphasize we do not want people using DAX as a placement exam because it's not designed for that purpose, right? And so that's my long-winded explanation of validity evidence.
Thanks, Angela.
You're
You're
welcome.
always better at explaining it than I am. Well, I'll just add for us in consequences, something we've talked a lot about is like with DAX, if someone tried to use it for high stakes decision making, we would consider that an invalid use of that measure because
Yep.
that's not what it was designed for.
Yeah.
Okay, so let's do a little case study. So, kind of related, say we want to test the effectiveness of a cognitive behavior therapy on chronic fatigue syndrome, right? And so in our particular case study, our situation, we have 142 patients who were recruited, right, from doctors. You put out a call, right? And then in our study, we take that 142, and we actually end up with 60 patients that are going to be in our study. And the other 82, if I'm doing my arithmetic correctly, are excluded for a whole host of reasons, right? Different diagnostic criteria, have other health issues, right? So we say, well, they can't be really part of our study. Okay. So this is an old example, but it's kind of nice because we can kind of talk about this in two different ways. Like when we think about how we collect data, we are generally interested in making two inferences. One is a causal inference, right? Not always, right? But in this case, we want to know if this intervention has a positive or negative effect versus doing nothing, right? If in the data science world, right, we often refer to this as A/B testing. Like Google's made this famous over the last 2 decades. Right? They literally A/B, which is just a randomized control trial, everything from the color of links to whatever, and they see how people behave differently, right? But this goes back a very, very long time, right? This notion of how do we estimate causality? And I'm going to talk about it a little bit more detail and more philosophical, theoretical point of view in a moment. But for now, we think of the randomized control trial as the gold standard for establishing causality, right? So we want to establish causal effect. The other thing we're often interested in is generalizability. Like, so we measure something, whether it's a causal effect or just like, who likes peanut butter, right? And we want to say, what's the proportion of the population we do that for? Right? So we want to generalize from our little sample to some larger group, right? Election polling is right. It's about what makes them good or bad is how generalizable they are. All right. So in this case, we have a treatment and control, probably pretty self-explanatory. And we get some results and we see that 70% in the treatment group had a positive outcome versus 19% in the control group had a positive outcome. So there's a clear difference here. Um, and so we could maybe make some statement. And this course, at least the first half of this course, is going to be laying the foundation for how do we know, or how do we know that this is a real difference versus just occurring because of random chance, right? So, statistics is more broadly is like sort of the measure of uncertainty, right? We're going to try to quantify how certain we are of some outcome or not, right? And we're going to talk a lot about coin tossing and then dice in the beginning part because it's pretty easy, right? Coin, we expect, right, 50-50 chance you're going to get heads, right? And if I flip a coin 100 times, I expect to get 50 heads and 50 tails. But if you got 55 heads and 45 tails, right, that could just happen because of chance, right? How far is it, 60 40, 70 30, 80 20, somewhere in there, right? We would probably say, that's probably not because of random chance. There's something wrong with the coin, right? Or the coin might be weighted, right? And so we're going to, over the coming weeks, going to quantify that, right? That big difference, 51%, could be real, no, given the data, just sort of my intuition of doing this a long time, it's probably real. Right. That's a pretty big difference. All right. So that's sort of, is this an effective treatment? So the second question is, okay, let's just stipulate it is a positive effect. Can we say that cognitive behavioral therapy is an effective treatment for the entire population? Not really, actually, because these patients weren't randomly selected from from the population at large, right? We whittled them out for a number of reasons. So we need to start being a little bit more specific and say, well, we know this is effective for people who have these preconditions, right? Already have, established, have chronic fatigue, but don't have these other health conditions that we saw that cause us to exclude them, right? So we need to kind of define that, and that's the generalizability of that result. Now, that generalizability comes into play not just for experiments, they can just be anything. Like I said, polling, right? We want that to be generalizable, but we're not necessarily making any kind of causal claim. So on the sampling side, right? Typically we're working with samples, right? A lot of the origins of statistics, of like with Fisher and Tukey and Pearson and all these folks in the last century who were developing some of the methods we use now, is a large part because they had to work with samples, right? And then William Gossett, we'll talk about him, my favorite statistician who tried to solve one of the more important problems in the world that we'll talk about in a few weeks. Right? They had small samples because getting data was expensive until the last decade or two. Right now, data is available everywhere. There's a plethora of data. So sometimes we have census, right? The United States, censuses are so important that it's written into our Constitution that we do it every 10 years, right? Because the founding fathers, when they wrote it, knew having an accurate count of people in the United States was going to be important. But it's also very expensive to do, right? Which is why we often rely on sampling techniques. So when you're doing sampling, right, there are problems that occur, right? Non-response, right? That creates a bias. Is there a systematic reason why someone didn't respond or not? And I've been doing some interesting work where in our DAX, right, we're trying to do predictive models, but then we get some students who choose not to engage with the intervention, even though they're in the treatment group, and even though they were told it was a requirement, they still don't do it. And then, right, and so this kind of connects into what could be considered a missing data problem, right? And so this past summer, I did a presentation on a package to handle that in a predictive modeling context where you have a non-response bias. We're trying to model that out. So it's not detrimental, but you need to be aware of it. Voluntary response, is another one where you just put a poll up. It's like, who sees your link, right? So that's going to define your population. The population is anybody who could have seen a link, who had an opportunity. But then the second question is like, why do some people respond than others? I think this is a huge problem, like on Amazon reviews, right? People tend to write reviews if they're really mad or extremely happy, right? And maybe more likely if they're really mad, right? So that's a voluntary response, and it's kind of, that represents a response bias. Lastly is convenient sample, which is like, I might want to do a study and I'm just going to ask all of you in this class to do it because you're here, you're convenient, right? And so what does that say about my population? I could say something about maybe SPS students in data science, but can I say something about all students in the United States? Probably not, right? So that's a big problem, and that's actually a big criticism of like psychological and social science research. A lot of a lot of the things that we, pop sci that you might hear about is, the result of sampling, undergraduate college students who happen to be around and who answer a flyer to, get pizza or something to participate in a study, right? So that has generalizability problems. All right, in terms of sampling, right? So if you imagine we have some population represented by all these dots, simple random sample, just randomly selecting a certain percentage of them. Pretty straightforward. But there are other kinds of sampling things you should be aware about. So stratified sampling. Can be really effective if there are, say, some variables that you think are related to your outcome or that you want to ensure that you have representation, right? So I imagine things like sex and ethnicity, right? Social economic status, where I want to ensure that I get, my sample is representative of those different groups. So I may divide the people who are my population into these different strata, and then I randomly select within each of those, right? So from an educational context, like in the School of Professional Studies, if we want to, survey students about their opinion about something, we might stratify by degree program and then randomly select within degree programs to ensure that all degree programs are kind of represented, right? So that we don't get all of like, you know, the, social, the whatever data science students answer because we like data and we're going to do it. And then you get some other program and nobody answers. Last one is cluster sampling. This one's kind of unusual. The only example I can ever really think of is like these national studies done by, say, the Department of Ed, NSF, OECD does one called the Program of International Student Assessment, right? But let's talk about some of the educational ones, so National Assessment of Educational Progress, for example. They want to, measure student performance in grades like 4 and 8 every 2 years, and they've been doing this since the 70s. But if you just did a simple random sample, right, you get one student here, one student here, that is really challenging, right? I'm going to go to this school just to measure this one student. So instead, what they do is they randomly select schools and say, okay, this school is going to be in our study. And then they go to the school and say, well, we're going to randomly select a bunch of students within that school, right? So that's a cluster sampling. In that case, it's done for logistical reasons, right? And if you encounter these kind of data sets, you often see things called weights in there, because when you do this kind of design, not everybody has an equal likelihood of being in the sample. And so they can actually calculate the probability of being in the sample and adjust how their weight to whatever estimates you're doing, which is kind of an interesting thing. This came up. Oh, there's somebody. What is going on here? Um, uh, was someone trying to mouse over? That was interesting. I never saw that before. Sorry if I got distracted. I don't know if anybody saw that. There was a name popping around across my screen. Um, there was a famous example, I think, when Obama was running against Mitt Romney. And for a while, it looked like Mitt Romney was winning among black voters, like in mid America, and that was because there was like one black respondent in an area with a low black population who said he was going to vote for Mitt Romney, and because his weight was so high that it kind of really skewed when they used the weights. So sometimes weights can be problematic. It took a week or two for that to kind of even out because they collect more data and do stuff. If you're interested, you could probably Google it. I think Nate Silver may have written about that a while ago. Okay, last thing. So no, not last thing. I want to return to the experiment, right? We're going to define correlation mathematically, statistically in a couple of weeks, right? There, and what does it actually mean? But sort of intuitively or sort of from a broad view, a correlation is going to be a measure of relationship between two variables. Ranges from -1 to 1. We'll get there. So, a lot of times we have observational studies and we're going to see, we could have an observational study that says, okay, this person had cognitive behavioral therapy and this one didn't. And we could say, oh, there's a correlation. Those who did it might are more likely to have an outcome. But from an observation, if I just on my own choose to go get cognitive behavior therapy because I have, yeah, that could be there, but that's just a correlation. That's just a relationship, right? The experiment, right, is going to define whether or not that's true or not. And so remember, correlation doesn't imply causation. Sort of, I think I covered all these. Just a few other terminology here that you should know. Placebo is like fake. This is most common in medical world where, if you're in the control group, you're going to get a sugar pill, right? And the idea is you don't want the people in the control group necessarily to know whether or not they're on treatment, which kind of goes to blinding, right? So blinding is individuals don't know which group they're in, right? If they're in treatment control. Again, very, very important in sort of drug research, medical research. Placebo effect is this notion that there's an improvement in the control group who are receiving the placebo. And this is actually a phenomenon that is currently unexplained. It pops up fairly frequently, and it's sort of I think Science once listed it as one of the um, most misunderstood or least understood phenomena in science, right? It's one of the biggest outstanding questions. We don't know what's going on there, right? So people who just think they might be in the treatment get better. So it's kind of in that if you're in the medical or biostatistical, that might come up. Double blind means both the experimental unit and the researcher who interacts with them don't know who's in the treatment and control. All right. This slide tries to summarize everything I talked about, right? So we got random assignment, we have random sampling, right? So the ideal experiment means we randomly sampled and we did a random assignment, right? That's going to give us causality with good generalizability. Very unlikely, extremely unlikely, right? What really happens generally is, well, there was no random sampling, but we did do some random assignment. And that's what most experiments are, right? If we have no random assignment, right, we're just measuring things, which is fine. And it was a random sample, that's good generalizability. But if we didn't, right, we just have bad observational studies, and those could be harder to work with. All right, last bit again on causality. I bring this up only because like my research area is in quasi-experimental designs, and I like to, maybe belabor this point a little bit more. So and also Angela and I and another colleague, we have a paper out for a conference review that we title something like, I can't remember exactly, like free will is an obstacle to estimating causality. Did I get close? I can't remember exactly. Um,
Yes, yeah, it's RCT. Free
yeah,
will is
RC.
an obstacle to a successful RCT or something.
Yeah, okay. So and I make this argument, right? This isn't a new argument. There's some, you can read Cochrane and Pearl wrote a lot about this in the 70s, but you can go all the way back to like Aristotle's who wrote about, how do you know what causes what, right? And I like Rubin's causal model because he talks about, kind of frames this as a missing data problem, what causality is. But in reality, right, if we have some research subject, a student, a patient, mice, if you're doing lab work, right? What we want is to take that research subject and split the universe in two, such that the only difference between those two universes is in universe A, we give a treatment, and in universe B, we don't, right? Or something like that, right? We have one little thing like time, environment, space, temperature, literally everything has to be, right? Think Marvel multiverse, right? And then at the same exact time in these two universes, we measure something on that individual. And the true causal effect is the difference in that individual at that point, in these two universes where the only thing different was this treatment control condition. Right. Rubin's student who wrote a great paper in 86 actually coined the term and called this the fundamental problem of causality, right? Which is a great phrase if you've done calculus, right? There's a fundamental problem of calculus and yeah. Anyway, so this is impossible, right? So a randomized control trial is merely a um, the best thing we have. So what a randomized control trial is saying, well, I'm only going to, for each individual, I'm only going to observe outcome A or outcome B. And if I funnel enough people through such that their path to condition A or condition B is random, right, 50-50, then all of the other variables that could influence outcome A are going to balance, right? So they would in fact, they would impact condition B and condition A, right? Everything balances out is the argument in the randomized control trial. So let's look at this as an example. Is this true? So on the left here is my figure. So what I did is I randomly generated 30 observations from a normal distribution with a mean of 100 and a standard deviation of 15. Okay. This is just a simulation. If you want to be concrete, what I'm saying here is here are 30 individuals and I measure their IQ, right? Because the IQ measure is designed to have a mean of 100 and a standard deviation of 15. Okay, so imagine those are the blue dots. Randomly generated 30 observations. I'm going to stipulate that I have a treatment, right, that increases everybody's IQ by 4.5 points, right? That's the true causal difference, the counterfactual, right, which we can never see, right? So for this individual, right, they started with an IQ of, say, 80-ish. I'm going to say if I give them my treatment and at the end, they're going to get their IQ would be 84.5. Okay. So each of these black lines is exactly 4.5 units wide. Okay. So far, so good. So what is a randomized control trial? Well, it means I'm going to only randomly see one of these two measures for each individual. So here on the right-hand side, I do that. I do one randomized trial. So for this first individual, they were assigned to treatment. For this second individual, they were assigned to control. Third looks like treatment, control, and then a bunch of treatment, right? You see what I did here? I just picked one outcome because I don't see the other. As Holland pointed out, I only see one. So under this randomized control trial, my estimated difference is minus 5.3. So not only am I not close, I'm in the wrong direction, right? So this randomized control trial would give me a very different result than what I had. Now, as we will go through this semester on this slide, there's a lot of R code here. In summary, what I'm doing here is like repeating this 500 times. So I'm using the same 30 individuals. I'm just going to, do a random selection 500 times, measure the difference at the end, and that's what this histogram is. So if I replicate my study over and over and over again, well, the mean of across all those replications is going to get really close to what the true difference is, right? So there is a red and blue line here right in the middle. They're right on top of each other. So if I do this over and over again, I'm going to get to the true causal effect. But note, like here's 0. This is a null effect. Look at how many of those randomized control trials, would we estimate a no effect, but there is actually an effect, right? So, and, there's a couple of things here. One is, a couple of ways I make this argument. For tonight, I'm just going to say replication is really, really important in order to kind of understand where, particularly when you have wide variability and things. All right. I'm happy to take questions. I saw a couple come in the chat, so I'm going to scroll back and look. I'm going to put a link to the 1-minute paper in here. Okay, so somebody's explaining. If it says anywhere that you need to submit the RMD, that is not necessary. Just submit the PDF. I need to do some more searching and replacing. We'll ask for the RMD if we see some issue, but I think if you just submit the PDF, that will be fine for the labs. Because I don't think Brightspace will let you do that. If you put it in a zip file, that's fine. Really
Yes,
don't like zip files because it slows down my grading because you have to download it and do it, where a PDF I can just view. Okay.
Jason, you froze for a little bit, and so you might want to reiterate what you were saying about RMD files.
Don't submit RMD files.
Not even as zip files.
Not even a zip file because then I have to download the zip file. It's just a pain in the neck.
Yeah, just a PDF.
if I see a major, if I'm grading and I like, oh, so you're having trouble, I might ask for it. Or if you message us on Slack or email us and you're like, this isn't working, sending us the RMD file is often very helpful for us to debug what's going on. That's the time to share the RMD. But in terms of the
Yes.
final assignment, just submit the PDF.
Yes.
Sophia has her hand up, and then I'll go back to the chat. Go ahead, Sophia.
Right, thank you. So when I tried to knit to PDF, it was like, came across a code chunk that was looking for the image and the image wasn't there. So I'm thinking that I mean, not thinking, I know there's something wrong, but how do I get, you wanted that PDF to have the images you included, to have the code we included. What was I missing? Because it froze or the execution halted because it couldn't find that image. So I want to know what I
Yep.
need to do for next time.
Yep. That's a great question. So I don't think there are any other labs that are going to have that issue, but I'm going to suspect, did you just download the RMD from the website and start working from that?
Yeah, I downloaded, yeah, I just opened the RMD
Okay.
into R and just, or R Studio and just started working on it.
Yeah,
Yes.
let me see. I think that yeah, so I did that as a shortcut and now I kind of regret it. Um, so what I would recommend is if you load the Data 606 package, and the instructions to install that are on the software link. It's right here, this line here. So if you load that, there's a function in there called start lab, and I could do say lab one, like so. That is actually going to create a folder. Oh, I don't know why I'm here, but that's fine. So here's a lab one folder, right? And so it opened the RMD file for me, and there's that image file it was looking for that it couldn't find. Um, but most of the time, that's not necessary. I'll figure out a fix in the future. So if you use the start lab, so now for this week, you're going to do start lab two, and that's
Okay,
going to
so we
create
should
a
use the spot
folder.
lab function.
Yeah. So
Okay.
any kind of supplemental files that are necessary will be there.
Okay.
Um, so sorry about that.
Oh, no worries. Thank you for explaining that.
Yeah. The other thing you guys should be aware of, I think this might have came up last week, is this notion of working directories. So right now I'm in this, I don't know why I'm in this working directory, but that's where I am. So there's a function called getwd, which is your current working directory. Now, when you're doing knitting an RMD file, our studio behind the scenes is going to set the working directory to wherever that RMD file is. So if we go to, let me actually open lab one. So okay, here we go. So where is that image? Okay, so if I run this line right now, I get this error. It says it cannot find the files image, you know, our interface. That's because my current working directory is here, which is also reflected in our studio right here. You can always click this arrow and it'll take you to the working directory over here in the files tab. So it's looking for a directory called IMG. I don't have a directory called IMG here. That's in, it's right here because it's needed for where the lab is. So you can always do, I could say more set as working directory. So no, over here, now my working directory is lab one. So when I do relative file paths, it'll be relative to here. So if I rerun that command, I get this, which is in R console meaningless, but it means something in the R markdown. So now, so this is sometimes an issue. I tried to alleviate this a while ago when I made updates to all the labs where like this was an issue when we were loading data files, but now all the data that we use comes from an R package instead of a file on disk. But I'll give you this heads up. If you're in 607, like this working directory issue can really hang you up if you're so I always tend to create projects and then my working directory should be the root of that project. So if I actually switch here, if I go to, I can't. I messed something up over here. But yeah, if I open a new project, my working directory is going to change. But you can always see it here. But there's also a function called get WD. There's also a set WD. I hope that's clear.
So that's what I was going to also ask. So we should set up a new project for each lab. In that case, that's going to be our working directory, whatever we set as a project directory, right?
That's up to you. I would just create a one data 606 package and just create subfolders for each lab. But that's you could do whatever you want. Either one is fine. Um, some students don't set it up at all, but you can always in the file browser, once you get to the lab, under the more, there's the set working directory, right? And it's just really calling that command. And then you can work from there. That's fine too. Um, what I like about projects is when I switch to another project, whatever files I had open last time are reopened, and I can kind of just pick up where I left off. This web version I have is out of date, and I just noticed some things were messed up earlier today, so I'm not going to go too much further. Um, okay, did that. Why pull? Okay, so Samuel's asking like. I'm not a pollster, so why have the polls been wrong in many elections? So recently, at least in the last election, the polls were actually kind of accurate. We're going to talk about standard errors in a few weeks, right? So what you need to pay attention to and what journalists often don't state, the pollsters, I'm sure, give them the right thing. They're going to say this candidate A has 51% of, we estimate 51%. The standard error, plus or minus 3%, meaning that could be anywhere from 48 to 54%, right? And we're going to talk about confidence intervals and what it means. But it's like if we repeat this, the true estimate. So when you're estimating and the proportion is really close to 50%, the polls 50 is in the standard error, right? And we're going to talk about, null hypothesis, where oftentimes we think about the null as 0, but in the case of polls, the null is 50%. So the null is in the confidence interval, which means no one is statistically ahead, right? We don't have a lot of confidence. So I think that's why that works out that way. And we're going to, we'll show some examples. Now what used to work, right? I think in the early aughts, Nate Silver from 530, you then created 538, but he became famous when he was at the New York Times, where he accurately predicted, I think, nearly every congressional race. And what he ended up doing is developing a model that aggregated all the polls that are available. But then he started weighting polls based upon each poll's past history, right? So in the last election, you take Fox News polls tended to favor Trump. MSNBC polls tended to favor Kamala Harris. So you take historical data, he started to estimate the leanings of different pollsters or their accuracy. And so could take that into adjustment. And actually, if you take the average of polls, he for a while that really worked really well, but that doesn't work really well anymore. For reasons that I think are partly statistical, partly political science, partly, there's a lot of complications there. So I'm glad I'm not a pollster. That's really hard. And but we will talk about some of the principles about why that is. And if you just look at the last few elections, they're always, I think the winning margin is, if you look at just the popular vote, okay, it's just 1%. United States is hard because we have an electoral college, so not everybody's vote is equally weighted. So that's another layer of complication that pollsters have to deal with. So anyways, I digress. Oh, now I see I'm frozen. Sorry about that. Link to 1 minute papers. Is this chapter 1 or 2? This is kind of chapters 1 and 2, I think. It used to be just chapter 1, but they split it in the latest. It's kind of a little of 1, little of 2. Okay, other questions?
The question, I had difficulty with the last with the lab. I had a lot of difficulty saving it as a PDF because I used the R package, to load the lab. We're using that function you showed. And I don't know, because at the top it was saying HTML and PDF. So I had to like get rid of the HTML stuff. And I don't know if anybody
Oh,
else,
um,
so
uh,
otherwise, I don't know. And because I was,
so what you could always do is there's a little arrow next to the knit button.
yeah,
If it's knitting to HTML, you can just click that and there should be a knit to PDF. And
right. But it was stuff that like it was in the top, like the code. And I don't know if I just like manually got rid of it.
yeah, you could delete this bit here.
That's
So
what I
yeah,
did.
that would be fine. That's another way to do it. So with our markdown, you can define multiple output formats. And so all of this is, you know, parameters for when it knits to HTML. And then we really don't have any parameters for PDF. We just do the PDF. But yeah, so if you, oops, so what it often does is, I think if I knit to HTML, yeah. Did you see what happened there? It put HTML before PDF. And so now it rendered as a PDF, but I mean, as an HTML file. Now, if I knit to PDF, you see it change the order. So when you just click knit, it's always going to just render whatever the first output format is. Um, I left the HTML because occasionally I rendered a HTML to post it somewhere, but um, does that help, Denise?
Yeah, I mean, I just deleted that part. And I also learned from the other class and by mistake I made that don't um make use the same names for your code chunks because it'll mess you up.
Yeah, it won't. It will throw an error if you use the
Yeah,
same name.
I mean it won't. Yeah, it will cause you problems.
Yeah. Um, I I'm a pretty bad at naming my code chunks. I just leave them. Um, except, a few cases. So the advantage of naming your code chunks is if you get an error, it'll tell you you get a label instead of saying code chunk 13 had an error. But I don't know if you notice right here in our studio, you can actually the numbers are fine because it numbers them for you, and you could just navigate to different code chunks as so it's there for your convenience. Um, I only ever really care about the labels when I'm collaborating with someone else, and I might need to, talk about it. When I work by
Because
myself, I almost never label them.
I don't have to, right? That's yeah. That yeah. I mean it was kind of messy, but I got it to save it as
Great.
There is a series of questions Rebecca asked earlier in the session, and during today's meetup about midterms and finals that I
Oh,
wanted to, could we reiterate so others
yeah,
can,
I typed it. I typed the answer because you were chatting
yeah.
about the midterm and the final. So I'm recognizing that uh it's not there, but I think it is in Brightspace. So the midterm is 20 multiple choice questions. I think it'll be available on Monday since we're doing the meetups on Monday. I think, is that right? And it's going to be due Monday.
I think it's scheduled for the midterm, it's scheduled to go out on the 6th, and it's on Brightspace at least, and you guys have to submit by the 12th. So it's
Okay.
due on the 12th. Yeah.
Okay. 20 multiple choice. You can, once it's available, you can open it, you can look at it, you can come back, you can use your book, you can use your notes, you can use the slides, the course website. We just expect you to do your own work. So I don't, it's sort of just a sanity check to make sure everybody knows, what we think you should know. If we see there, there has been consistently one topic that I do not want to say, Students should absolutely not get wrong, but still get wrong. Um, I will I will get I try to be a little goofy about it, but there is like one thing that I'm pretty adamant about. Like all my colleagues make fun of me, but my passion about this thing. And then there's a question on the midterm about this thing, and students still get it wrong, which is but otherwise, historically, students do generally do pretty well. I don't think we've seen any other than that one thing, any major systematic problems, even on some core concepts that we want you to know. So the midterm is really just sort of a check-in, make sure you're there conceptually. The final exam you can think of as like a middle mini lab. There is a few multiple choice questions, a few short answer, and then you're going to get there's some data sets to analyze.
Yeah.
We are not out to trick you. I honestly would not worry about them until you see them. Don't even think about it until whatever the date is on Brightspace. I'll put it on the website. I don't know why it's not showing up. And yeah, so they will become available at a certain time. But I think the dates are visible in Brightspace, I hope.
Yes, I believe so. Samuel asked if the midterm is challenging. It would be challenging if you don't do your work, if you don't submit, if you don't follow the course as it progresses, right? And you wait until last minute to do all the studying, the cramming, and then yes, it would be challenging, even though it is an open book test exam. But if you're following along and you're doing the work when it's due, and asking
And
questions
attend the
and being
meetups.
engaged, yep, then it will be a piece of cake. Especially because it's open book, right? So as you're going through the chapters, you will know where you have to find the information you need to answer a particular question, for example.
Are they timed?
No.
Yeah.
Well, only insofar as you have to do it in that week.
Yes.
Yeah.
Yep.
And we can, I assume we can take it only once, right?
Yeah,
Correct.
only one
So
time. Yeah.
yeah, so don't submit until you're ready to submit, because once you submit, that's it.
Yeah.
Oh, one more
Yeah,
question.
the finals the finals under assignments, that's sort of a technical thing because it's not an exam per se, because you're going to download an RMD file to work with for the final. And the midterm is entirely in Brightspace. So don't that's just the labeling in Brightspace for how we structured them.
Yeah.
Want to ask also, do we get to see the answers after like the exam is closed?
No, but we are happy to meet and chat.
Oh, okay. All right, no
Yeah.
problem.
The
Yeah.
reason for that is test security, because we do reuse the exam. And so by us giving you the right answers, there's a risk of future students knowing what they are. So that's the reason. But we are happy to meet with you to review the answers and review. Yeah.
Right. So going to what we talked about tonight, like validity and reliability, writing good, valid, and reliable test
It's so
questions
hard.
is really hard. It takes a long time.
Yep.
So we don't want to make new ones every semester. We rotate through some, but yeah, we got a bank now, but yeah, it's hard. It's hard.
Yeah.
I don't want to do it every semester. You know, quite frankly, I think if you would attend the meetups, hopefully these slides that I have posted are enough of a reminder. Like, uh, Angela's been contributing the last couple of years. So I've been iterating on these slide decks for a decade. So, and I'll take feedback. Like if I'm missing something, that's why I love questions. Like every semester I go down some rabbit hole because a student asks a question. And like when we get to maximum likelihood estimation, that is like resulting in an entire like paper in our package because student asked a question and as I started thinking about better ways to explain it. So this, I can't emphasize the meetups. Like I worked really hard to distill the core concepts down to under an hour for each topic or each chapter. So I would do the meetups as like what we think is important. And then it's like, I need a little bit more. That's when you go to the textbook. So that's why we like to do them. So I appreciate you being here on Labor Day, because now the rest of the week you can look at the book, you work on the lab, right? And hopefully we laid a foundation for you. That's been our goal. I hope that's how it's working. So Um, yeah, for if you're still really nervous, reach out, can have a conversation. I've had those with students over the year. I actually had one last semester and she's doing extremely well. She actually had a PhD in another thing and she's like, "Man, this is really hard for me. I'm trying to change careers." And it's like, "You're doing awesome, right?" Like so I'm happy to meet and to talk you off a ledge if you're feeling, you know, anxious about this. That's not our goal. Like this is I believe if you just put time on task, you'll get through it.
Yeah, one of the things that we do recommend, I think it is on the syllabus, are they're not required, but they're homework questions in the lab, I mean, in the textbook. And so if you want it as a form of self-assessment, like how well do I really know this content, do some of those questions and see. Because if you're able to go through them and say, yeah, I understand it, I can complete this, then your understanding is there. It's you've mastered the understanding, right? The questions that we picked out I believe there are the odd number questions for which the textbook will provide you with answers and explanations. So that's a good way, a good form of self-assessing.
I'm still working on my stat and R chatbot, so that could also be
Oh,
another.
that'd be so awesome when that works.
It works, it's just really slow.
Oh, I see.
So it may end up just being something you have to download and run on your own computer. Because I don't know if I can afford the server space
Uh,
to host it. Um, and I have it configured by default to use Llama, which is
mhm.
free because you can
Yep.
just download Llama. Although I also have it working with Anthropic because I tend to prefer that one for programming stuff,
Right, right.
which should be faster, but my local model is a gigabyte of all the resources. So I think that's the problem.
Yeah.
Yeah. Changing. I think I said this last week. I mean, coolest thing about this is like the versatility of a data science degree or statistics degree. I tend to use statistics and data science interchangeably because they more, the Venn diagram of those two things overlap quite a lot. But you get to, yeah, and you could do anything, right? Literally every field needs a data scientist now.
Yep. Yep. I met someone at a conference, at a Python conference. I met someone who worked at Sherman-Williams, and we got talking, and we became good friends during the conference because we shared the data analysts at analyses, geeky um, interests, right? But she's working for Sherman-Williams, and I'm working within the educational field. But we connected because of that, and so that's pretty cool.
Yeah, I was at the New York R conference last week, and last talk was a data science for the Yankees who was trying to predict attendance of games using all of these different variables. It was fascinating. I'm not a Yankees fan. I don't really watch baseball anymore, but it was like, wow, how cool is, and what was the one, and then there was another one, a medical person before, and then anyways, yeah, it's just the variability of topics is huge.
Yep. I want to address one of Tatiana's question about is there a rubric for the labs? There is no rubric for the labs. The purpose of the labs is for you to as you're going through it. It's a learning process as well. And so we usually grade for completion. That said, the more you don't have to go insane in terms of adding as much details as you need, but I would say it should be sufficient for us to know to what extent or if you understand what is going on, right? And so if you just give an answer, that would be harder for us to know, oh, well, are they understanding it or are they just going through the procedures and not really knowing? So the interpretation of the the answer, I think, is important for us to know whether or not you're really understanding that in the statistical concept kind of way, if that makes sense.
Maybe we need to write a new exam where we give Chat GPT responses that are wrong and ask students to say,
Oh,
why is it wrong?
I like that idea. Sorry.
So there were a lot of
Well, there it
LLM
is.
there were a lot of LLM talks at last week's R conference, and so Max Kuhn, whose name, if you're not familiar with, you will be, because he wrote Tidy Models package in Carat, and he's a prolific writer. He's written a number of really good textbooks on predictive modeling in the R community. He's just really unbelievable contributor to the community in terms of important packages. Um, so he's been working on uh sort of LLM metrics. Anyways, in some of the results he was showing, like how trying to quantify LLM responses into like completely wrong, partially correct and correct, right? And I think like only a third could you say were really correct. Um, Looking at prompts related to like R tasks, right? So they were doing some stuff where you could more easily verify that what the answer is correct or not that it's giving, right? I mean, there's some criticism, right? So you can ask all the chatbots how many R's are in strawberry, right? And they get it wrong, and that's because they don't work like humans. Like they're as we go through. If you, I could give. There's some bits I understand, some bits I don't understand. Like, um, you you know, in a lot of ways, what's happening is it's just trying to predict the next word based upon the previous words, based upon what it's seen on whatever it's trained on. And it just so happens that when you train it on like literally the entire internet, human languages fair becomes fairly predictable in many ways. Even though, I always remember, I think it was in a philosophy class, and one of the assignments, this is when I was an undergrad, a very long time ago. I remember a professor saying, your assignment is to write a sentence that you're pretty sure has never been written before, right? And that's, you know, actually, I should ask that to ChatGPT. Write a sentence that you think has never been written before. I wonder if it could give a response, right? And you could put all sorts of crazy words together, and it's like, yeah, that's probably never been uttered before, but um, I'm not sure LLMs can do that. Yeah, I won't get to labs in probably Wednesday, Thursday. I'm hoping to grade.
Yeah. And we found this pretty helpful and useful. So we'll emphasize this here too. If you have any specific questions about your labs as you're doing them, please include those questions or concerns in the lab. You can make them different colors if you want, so we're sure you're to be sure that we do see them. But by doing so, it would help us focus our feedback. Otherwise, we tend to not provide as much feedback as, especially as we're moving to the later lab, since we know that you're used to it and you're familiar with the process and everything. So do that, and then we will respond to the questions.
Well, I'm going to give ChatGPT some credit. I'm going to guess that sentence has never been written before. Okay.
Does it even make sense?
Is it grammatically correct? Okay. Interesting. All right. Uh,
Just a quick question. Is there a penalty if you didn't do Start Lab?
no,
No.
no, nope. They're identical if you downloaded it. And the Start Lab is just there as a convenience.
Oh, okay.
Oh yeah, there is like you can make it go flat. I mean, there is a horrible story. I don't even really want to talk about it that happened in the last week about um some people using ChatGPT for like therapy and things like that. Please don't do
Oh,
that.
yeah. Don't do
Just don't do that.
that. No.
Um
Talk to your friends. Talk to us.
yeah. 988 if you need to, right?
Hmm.
All right, everyone. Yeah, we can call it a night.
Thank you, everyone, for showing up.
Yeah,
We
on
appreciate
Labor
it.
Day, nonetheless. I hope this. Have a
Thank
good
you.
one.
Thanks, you too.
Bye. Thank you.
Bye bye.